Hi guys, welcome to yet another part on our Formatables Refactor. So on our last video, we're getting quite close to solving our problems. We're down to 6 failures now, and all these failures are related to C#. And we figured out that the problem was to do with the fact that we are not processing the C# path, project path correctly. And so what we'll try to do in this video is try to resolve this issue. Let's make sure everything's alright with the recording, seems fine. Right, so what we need to do is we need to go to our transform, legacy paths transform, and we need to, for some reason my sound doesn't appear to be correct. Hopefully the recording is alright. We need to do a bit of a hack here. One more hack in a series of many hacks that we've done in this legacy transform. So this next hack is going to be to have two project paths. This is going to be a C++ project path and a C# project path. Now, it's fine to just have it completely hard-coded for now because as you can imagine, this is just purely to get us move from step A to step B. And by the time we get to the end destination, none of this will be used, so it's not a big problem. So what we need to do here is, when we're creating the project path, we need to take into account the backend. And as you can see here, we are searching for the backend by ID, and the backend ID presumably is going to be hard-coded to be C++. Right, so then we need something like two backend IDs, something like this, and then we need to supply whatever that type was. Probably should have bookmarked it. So we need to supply this guy here into the method, which would have been project path. So this guy here. So the idea being then that we are going to give the project path to the guy, well, we're going to give the backend ID for the supplied backend. Righty, and then this hopefully would mean here we are. So this guy here. So instead of hard-coding the backend ID, we will want to supply that as a parameter, and then all of this will work just fine. We just need to make sure that when we're making the project path, which will happen twice, so we need to make the C++ project path, and here we will just have to supply the TPP backend ID. Right, so let's just make sure we know what we're doing here. So in this particular case, we are supplying this guy here. Okay, cool. This is now making a bit more sense, and then of course we will need something similar for C#. And this guy will just basically be the C# backend ID. If I could spell. Okay, now we created two project paths, and everywhere where there's a dependency in the project path, we just need to make sure that we're referring to the right guy. The hack that we're going to do is going to be that pretty much everywhere we will use the CPP project path. The only exception is going to be going to have one simple exception here, and that exception is going to be the C#. Right, so when we're creating a full path for C# and we ask for a facet path, and we say that is true C#, what we really need is for the facet path to be able to determine that in C#, we just have to be very careful here. So we have project path properties. In fact, I don't think facet path is going to be too affected by this, because I don't think facet path has the full path. You can see we're creating the path here, and we start off with things like the facet properties. Let's just look again at this C#. Make full path for C#. Not very clear to me exactly how this thing is working at the moment. So, and that's perhaps... No, that looks fine. Okay, no, actually it's even simpler than we thought. However, we would expect an error coming out of this, because clearly there is no such thing as a project path. I think, yes, okay, fine. So let's just make sure that we did get rid of the project path. See, one thing we should do that we keep forgetting is we should use the LSP rename, to be honest. Because if we'd LSP renamed, then everything would have been written correctly. Right, so now let's think about what we're trying to do here. CPP make headers path. So that looks fine. Make full path to implementation director again. We probably just want the CPP, so that's fine. Similarly, at the moment we only use this in CPP projects, so that's probably alright too. Similarly, that's alright too. See, all of this would have been handled by the LSP rename. We should have just renamed the existing project path to CPP project path and then added a new one. Should have made our life much easier. Okay, so probably just have a few of these. And hopefully now that would take us there. Okay, now see what happens if we just try to run it. Now what we're doing is we have got two different project paths, one for C++, one for C#. Depending on the context, it will use one or the other. So if we did everything as it should have, okay, we didn't quite get... okay, now this is actually quite easy to explain. The problems we're having now is just purely to do solutions in CS projects. That's because I think you're going to find that these are hard-coded to use C#. So all we need to do now is to see the context in which these things are being used. We need somehow to know whether we're making this for C# or C++. Hopefully this is not too complicated. Right, so as you can see here, we are entering this method very much without context of whether we're doing C# or C++. It's probably alright, but somebody has to have that context. So we've already done a hack here to determine whether we are tests. Now let's think about this. How would we know whether it's C# or C++, right? The backend probably would tell us. So we could have a is C# by checking for the backend. That would be easy enough. And what did we do before? We had an is C#. Okay, this is C# is done because we know for sure that we are making a path for C#. And presumably that's then extracted because we know in the C# implementation. So this, in this particular case, we can't actually tell whether C# or C++. So we need to investigate. So we know for sure we have a way of doing this, which is to say pm n.location dot backend equals, and now sadly here we can't actually use what would make a lot of sense, one of these variables we created here, because these are fully qualified variables. So we can't do that. We just have to yet again hard code this. And then what we're going to do is we're going to say, well, if you're trying to make solution, so basically these three types here, Visual Studio, Project Solution, and for good measure we'll do this for the MASD targets as well, because I think this is going to be a problem sooner or later. So also the other thing is we seem to be requiring value quite a lot, so it seems to me we probably should just do something like because we know we just need the value, so it makes sense to ask for the value so many times. Right, so what we need to do then is to go to these three methods and we could just do a constable is C#. I mean, this is very lazy, but this is good enough for now. So whether you're a project or MS build, I mean, clearly we should only use MS build for C#, but there you are. Right then. So now in this particular cases we are using a full path to implementation directory. Presumably that's also going to need to know yeah, sadly we won't be able to get away without changing that function unfortunately. So so in this guy here we will need our usual hack, whether it's C# or not. But we can default it to false just to make our life slightly easier, given that the vast majority of cases will be false. So the hackery continues here. Now of course I will stress yet again that this kind of coding is only acceptable because we know that this is all temporary code, and this is really not what you should be doing in real production code, really, all these hacks. But it is perfectly acceptable to do these things if you are just doing this to get you to the final refactor, because it sometimes takes a while to get to the end destination. Sadly, we need to propagate this to the full path to project as well. And hopefully that will be the point at which we stop propagating this pattern. Hopefully. Right, so this guy seems happier now. Right, so then this guy here will also require some flag being supplied. Right, we are really hacking quite severely here. Hopefully you're not going to lose the plot entirely, but right, so then we are approaching, I think, something similar to the end destination for this hack. So let's just quickly then tell the methods above. So somewhere around here. Should we use the LSP fine definition and this sort of thing? Save us a lot of time instead of scrolling through things, but there you are. So I think we're going to need something like this. Solution, project. I don't know why we have two solutions, to be honest, but there you are. And I think that's about it. Okay, so now then. This guy here needs to supply to the next guy. Okay, now let's see if I can just do a LSB find declaration. No, this definition maybe? It's a bit strange that both the definition and declaration seem to take me to the same place. There you are. Okay, so this is a quick win. Fix this really quickly, and then we can look for this guy and just right. Now then, what are the remaining errors? Right, so in these cases here, we want to supply the EC# function, flag, and hopefully this will then take us to a compilable program. Okay, so now if we've done everything correctly, we should have supplied EC# across the board so that everybody can tell what backend they're working on, and then that would then result in finding the right project path. Of course, as you can imagine, this is all one big hack because it only solves a very localized problem. Imagine, for example, I had a different backend, none of this would work. But that's not a problem because it's not the end solution. Now then, so interestingly enough, okay, we seem to change the extension of the project file. So that's interesting. Right, so what we probably need here is something like this. ECX. We need to say we're joining a whole lot of things here. So if we should say something like this, const auto, or const string even. extension, and we will initialize this as follows. We'll say if is C#, then we initialize it one way, and if it's C++, then we will initialize it this way. And here we'll just pass the extension. So I think this is going to be almost identical. I think actually this may not work because these are strings, characters, and I think C++ may get a little bit upset with this definition. No, it doesn't really matter. Okay, that's good. So what we're going to try to do then is to say use a different extension depending on the type of project that you're doing, depending on the backend. I think we're getting quite close now. And what are we doing for time? 21 minutes. Okay, now then. So we seem to say very interesting. It seems that the path for the project is not taking into account the full model path. So no, it does. So what is the difference? Oh, it's the dots. Somehow we lost the dot in the middle of this quick hack. But this is another great thing about very good tests, is that you can do all sorts of hackery and you not have to worry too much because the tests are picking up all these differences, and you know for sure that you can change things. You can change the internals. Well, there we are. So finally, we managed to get to a point where we are no longer generating any differences. So this means that the new transform now can actually take over from the previous way of doing things. Now, of course, if you remember, I think I mentioned this in the previous video, sadly we can't just go away and start removing everything now very quickly, because as you can see here, this guy is responsible for the file path and the guard expansion. So there's two things, and the second bit we're not doing yet. It's a bit sad really, because at this point in time we could almost get rid of everything. I suspect we still use the locator internally for other stuff. But what we can do is, at this point in time, we should be able to get rid of all the make full path calls from the formatters. So that will be helpful. So what we'll do, actually, before we do anything else, what we'll do is we just have a quick look at the file path guard expander. I think this is a very, very simple transform. So we will see here full path being called, which is this guy here. And then, as you can see here, we then create the header guard. Now, the key thing for the header guard is this inclusion path. Without the inclusion path, we can't create the header guard. Interestingly enough, we don't seem to populate the inclusion path anywhere. And the reason why is because we have another transform, which is the Directive Transform, that keeps track of all the includes. That I think is probably not going to rely on the locator. Well, to be fair, oh, let me change this. To be fair, what we really want to know is we want to know how, if I take a template, and say if I go to C++, and then let's say I take well, I guess the headers are probably going to be the most likely affected by this. So let's just paste the template here. Let's look for includes here in this template. There we are. Inclusion path. So as you can see here, we're saying make inclusion path for C++ header, and this inclusion path for C++ header is used it will be used somewhere in the directives. So this creates a factory, dependency builder factory, dependency builder. No, I think the dependency builder actually just generates the includes. So we're missing something here. taking a bit of a round trip here just to double check something, but we'll go back to where we were. So let's just have a look at the directive group repository factory. We haven't touched this code for a very long time, sadly, so but here we are. So this is the guy we're looking for, I think. I think what this guy is going to do, if I just look for doesn't seem to look for include path. So some point here we must look for the include path somewhere. Got a nice one downstairs. Put it pause for a second. There's a noise. We were trying to look for how is the inclusion path used, because at some point somewhere we must have a collection of all the include paths for all the headers, and that is again a locator job. As you can see, the locator is being passed around here, so it's definitely suspicious. Compute directives. So as you can see here, we're going through the formatters, and then the inclusion path is computed here. So we won't be able to get rid of the locator just yet, so I think I have to give you some further noises. 1 more second. Okay, got a lot of stuff going on downstairs. Now what we're trying to say is, we're trying to say that this is a sort of a two-step process, really. The first step was we got rid of the full path. That seems to have worked quite nicely. I mean, we didn't really reach all the objectives that we had, because at present we still have this kind of weird setup where we populate the path properties, and then only for the cases where we need, we populate the actual file path. And then we do filtering based on whether the file path is blank or not to filter out artifacts. So that's all kind of really crazy and needs to be looked at. But at least we've now managed to get the file path to be populated by a regular transform in the legacy paths world, in the physical world. However, we can't get rid of the locator until we move inclusion processing to the new world. But we probably should try to do an in-between step, and that in-between step will be to get rid of all the full path related stuff. Now it may sound a bit strange why we're going to bother to do that, but it actually will prove that we really truly moved the file path processing to this interim world, because we could have forgotten somewhere, and perhaps we still are using the artifact properties. So the right thing to do is to try to say, okay, can we prove that there is no one relying... Oh, actually, I think one thing we did forget was to start clocking. We started around 12 o'clock, maybe? So what we're going to do is, first things first, we need to get rid of whatever it is we're working on at present. So as you can see here, right, so let's just start by saying, okay, let's save that. Let's start by saying, don't really need any more debug logic. So here we should say something like physical handle C# backend in path generation, legacy path generation, legacy path transform. Right, so that solves the problem at hand. Now we could say for these guys, we could say, well, we are now computing the path via so text dot cpp C# use legacy path use path computed by legacy path transform in assistance. Okay, so that kind of solves the immediate problem, and hopefully at this point, one thing we did not do, which we should always do, make sure we got the latest code generator with everything on it. Make sure Git is clean as it is at the moment, and then generate all models, and then we should ensure that there are no differences, and then run the tests, right? So this basically tells us that the code generator is generating exactly the same code as was before. So that's already a success. And now the second thing we're going to do to validate that we are really doing the right thing is we're going to say, well, I don't expect the file path to have any bearing anymore. So we'll get rid of that guy. So we'll just do it. Text.cpp JSON, and that would give us the usual JSON support. Right, so now we got rid of that guy. Now bad things of course are going to happen, as you'd imagine. Modified something here. As you can imagine, bad things are going to happen because of course we probably are still using the path in some places. So this will give us the errors. One place for sure is going to be this guy here. So we could quite easily remove it and just leave this guy. So with a bit of luck, now let's just see what else is still relying on that member variable. Okay, as you can see here, we are still right. This is interesting. We're doing some kind of validation. I think we could probably just replace all of that madness with this. Okay, fine. Okay, let's just not get too carried away here. So we need the artifact properties and we need the file path. So the artifact properties are used here. The file path is used here. And that looks a bit more sensible now. Soon we will get back to handling the header guards and the relative paths, the include paths. It won't be as complicated as it sounds. I think it will be really just a case of adding these guys here to our path properties. As you can see, we already have a relative paths container here. We probably will start with the simplest case. Basically the legacy transform will have to handle all the hard work that's being done by these directive groups. So that's going to require a little bit of thinking, but hopefully not too much. Right, now this hopefully will be the other assistant. Oh no, it isn't actually. Right, so let's see how much you can get away here. So what is an AST? Yes, the assistant. Right, so the assistant has got artifact properties and it's got a file path. We're trying to copy it across. Now what we're going to do instead is we're going to say, well, the artifact, with a bit of luck, the artifact should have the file path. So use that instead. Don't think we need the assistant anymore. In fact, we don't. So clearly this is all stuff that could easily break. Not quite sure what's going on here, but seems a bit unhappy, so let's just go look at it more carefully. Right, so once we took away the assistant, a lot of things started breaking. entirely sure if we need all this stuff. Don't really want to have to break the whole world because of this change, so we need to sort of try to contain the change slightly. The first thing is, let's just make sure that we can build a code generator. We can generate all models without any differences. Okay, that looks good. And then there we can run all tests in the screen. So that's really what we're looking for here. Okay, that's good. So what we'll do is we will remember this guy here, but for now let's just handle one problem at a time. So the job of this guy was just to remove, so text.cpp remove file path from artifact properties and deal with the fallouts. Okay, so that's done. Now what we're going to do is, just for good measure, let's try to understand what is going on here. So if we don't really need any of this stuff, perhaps we can start to remove the clutter. Now we will have to see how much of a fallout all this is going to have, because it could just be that now is not really the time to do all of this stuff, or it could be that it's something so trivial that we can do in 5 seconds, so it doesn't really matter. We just need to see how badly this breaks. Here we just seem to be changing something in the workflow. That seems easy enough to update. Well, it seems like it was easy enough. Okay, I'm very happy that this doesn't cause too much havoc. Okay, so that was actually very good. We somehow managed to prove that the new transform, so text.cpp remove unused variables in stitch transform. Right, so what that's done is it proved that the work that we've done in the legacy paths transform is more or less okay. It is actually generating the paths correctly, and by removing that from this guy here, nothing broke. So now the second step we're going to do is we're now going to say, well, if that was the case, then hopefully everyone relying on the full path, every formatter relying on the full path, should just not have to do that anymore. So this is a little bit more complicated, because now we're going to have to change the templates, and every time we need to do this, it always requires a bit of thinking. So let's just go through each of these templates and try to see where this make full path is used. So this guy has it, so we don't really want it to have a full path anymore, just the one, so we'll remove it from here, update the template, and that's it. Now this guy here will probably also have it. There is implementation. So again, we just remove that from the template. I think we broke something here. See, there was a namespace there. No, that's correct. So that's fine. We will take that as is. Now we go to this implementation guy. Again, full path here, get rid of, update element. Now, C++ helper transform header, helper, and helper. So all these guys are helpers, so it doesn't really matter. Okay, now we change this model, and if we regenerate it, and of course we need to do the usual dance, singing and dancing of updating the JSON model as well. It will be nice when we get rid of the JSON models. Right, now what we expect to see here is we expect to see a whole load of formatters that no longer have this method. And this is purely in C++. Similar exercise needs to be done for C#. Now, we attempt to compile this, and of course all hell is going to break loose, because presumably there's an interface somewhere that defines this guy. So what we'll do is, while that compilation is taking place, we will try to see if we can find the interface. So that's the chain. Somewhere around here there will be formatter, transform. I wonder what the interface would. Oh, actually, interestingly enough, it didn't break as you'd expect. It didn't break in compilation, it broke in linking, so very interesting. So what we've done clearly is we forgot some header somewhere. Oh yes, I remember now. So what's happening is that we got a base class, something like this. Right, there we are. So this base class here, which inherits from model to text transform, has a full path. And so what we want to do is we want to say, don't do that anymore. And now hopefully that now means, I'm not entirely sure if this will resolve the problem, but okay, now we're getting the other errors. Right, okay, fine. So now what we're going to find is that there's other cases where we don't really use the mustache templates. So that's fine. Let's start with CMake list, should be easy enough. The CMake list would be somewhere in builds. There we are. That's actually the testing one. In fact, to be honest, I suspect the whole of testing has some overrides for these. So we will just investigate all of testing. So these are the cases where we have local overrides to certain methods instead of relying on an existing template. Now, that doesn't seem to be the case here, so that's actually quite good. But just for good measure, I'm going to investigate all of these guys here, because I'm not confident. No, it doesn't look like it's. Looks like these guys are all relying on the top level templates, which is good. Means we've got them done already, so it's not here that the problem is coming from. Okay, now then, let's go back to what we were looking for. The ones where we definitely know there's a problem. CMake lists. These are here. These guys probably have their own overrides. Probably not very clear at the moment what the refactoring is doing for us, but okay, interesting. That is unexpected. So they are not overriding those. They are still relying on some whale or mustache template. That is puzzling. Let's look at that more carefully. So they have. Actually, let's just look at the error more carefully, because. So the build transform. No, we're barking at the wrong tree. Actually, the problem is not at all to do with that, and this is actually going to be a bit more of a tricky problem. The problem is to do with this is going to be quite a complicated problem. The problem is to do with the definition of the archetypes themselves. So we're in a meta land again. Right, so if I look at archetypes, see, as you can see here, that doesn't have what we're looking for, but I suspect if I keep hunting, we'll find something in the facets. One of these guys is defining a full path method. Interestingly enough, we're not finding it. I wonder if it's only the header file. It's not very clear where the header file is picking this up from. Let's look at this a little bit more carefully. So we are generating a transform. That transform is for the facet called builds. And that transform defines a make a full path method, okay, as you'd expect. This is the method we're trying to delete. Now, in order to know where this method is coming from, we need to find source make lists, the header file of it. The header file of it will be the archetype class header transform, presumably. And that would be, hopefully, referring to a template. No. Now okay, so this is making sense now. What we are doing is we are generating this code here. And now, of course, we're handling the C# case. Let's not touch that just yet, otherwise bad things are going to happen. Now, this is where things get a little bit tricky, because that looks very strange. I wouldn't have thought you need all of this stuff. Okay, something bad happened in this copy and paste, I should think. What we'll do is, just for a laugh, is to remove these guys there. Certainly should not be there. Okay, let's see what happens. First, let's have a look at the diff and git, because I think this is going to look very strange. Okay, somehow that template was still working. I have no idea how. That should have given us an error message. Somewhere, but I don't know why it didn't. Let's double check we didn't break anything here. So we have a stitch template that certainly should not have any of those key value pairs, unless, no, we're not showing anything more long. No, so that shouldn't have been there. So what we really want to do is to remove this bit here. But now, of course, you have to bear in mind that we need to regenerate this model with the previous version of the code generator. And then we need to convert the JSON model yet again. And now, hopefully, we have deleted. Now, of course, what you have to remember is that we just changed the code generator itself. And this means that the code generator is still, we are still having to, so all these things are still going to be in the generated code. And of course we can't generate a new code generator because the code generator is broken. So this is the sort of situations you sometimes get yourself into. Unfortunately, there is no easy way out. We need to manually update these files until we can get a code generator that generates, because we will only generate the right code once the code generator can generate again. So sometimes you get yourself in a loop where you're trying to update the code generator, and the update of the code generator results in a new code generator. But in order to generate this new code generator, you need to get the code to compile. And you won't get the code to compile because you can't generate the code. So it's sort of a loop. And so what we do in these situations is we just take a look at the code that should have been generated, where you were able to build a code generator, which is what we're doing at the moment. And you just make it look like it would have if the code generator was working. It's not really ideal, but it just simplifies things a little bit, because otherwise we would have to, it would be a bit harder. This is all generated code that you're seeing here that we're updating manually. And we wouldn't have to do that were the code generator actually compiling, as you can imagine. Hopefully we don't have to do this to too many. In fact, I think this is going to be a big of a... We're going to be here for a while, because I think there's going to be for every single model-to-text transform. We probably should have thought about the order of operations. I mean, there's ways and means of doing this. If we had done this in a certain order, we would have generated a code generator that generates the right code first, and then we would have made the change. But because we're kind of making the change as we go along, this is the sort of the expensive way of doing this. We're gonna get this error a few times more. I think we might just get a bit bored and start to think of a macro or something we can do to get rid of this. Because at the end of the day, these errors are going to be quite similar. We do have 90 formatters, so I think this is not scalable, I think. Right, okay, so what is the right way to do this? Unfortunately, it's a multi-line thing, so it requires quite a few changes. So let's get into the world of RG and grep. So we just need just the headers, and to be fair, only the headers and the transform. So let's just do a quick grep for the full path. Want that to be recursive, right? So that gives us all of these guys. You can see here, this would be too many for us to do this manually. Now we can't actually use wood-dyed, I don't think. Actually, let's just do a quick search. Emacs, wood-dyed, we'll grab even after lines. Let's see if we can do multiple multi-line grab. So we'll grab what was in it. Oh, okay. So we can actually give it context to grab. Okay. So let's see what happens if I do that then. I'm going to give the context of 3 lines, I should think. And that gives us just enough. But it doesn't look... I wonder if it's editable. Well, actually, do you know what? This is probably doable, but it's going to take us a lot longer. Let's just do it the quick and dirty way. So what we're going to do is open a macro. Macro is going to be next file, kill, 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 save, close macro. So very simple macro, and we're just going to repeat this macro. I think this should just work. I mean, we could definitely do this with grep. It'll be like 10 times faster. However, it's going to take us a while to get there, and it's probably easier to just do it this way. Nice if we could just leave this running and do Google searches in a different window to figure out if what's the right way to do this with grep. See, this is the one thing I like about using Git quite heavily, is that you can be very confident about the macros in Emacs because you get a chance to look at the Git diff. It's taking quite a long time, really. Where are we in terms of the big picture? Always feel like you can do it quicker, but sometimes you just have to sit back and relax. So while we're doing this, let's just talk about what's going on here. So we need to remove a method. That method is generated by the code generator. However, we made a mistake, and we instead of actually updating the template to delete that method first, and then regenerating the model, we got the code generator in a state where it doesn't compile anymore. And so because of that, we thought it would be quicker to just remove the cases where the generated code is incorrect manually. However, we forgot that every single text transform has that code, which means there's about 90 odd of them, so it's not exactly super quick to do this. The right way of doing this would have definitely been to generate the code without this method first, but that would have required us to be quite concentrated on what we're doing. This kind of changes to the code generator are very hard to do when you are trying to do a video, because you really have to be very concentrated with all the state in your head, and that's not easy to do if you're trying to record a video. Hopefully it won't be too long now. One of the main reasons why this is so slow is because we have LSP mode enabled, which means that every time you open up a buffer, LSP kicks in, and that does take a few seconds. If this was on fundamental, for example, this would be a few seconds. We should probably talk to the LSP guys and see if it's possible to make LSP slightly quicker when he opens up a new file. A little bit more in the background, perhaps. I think we are approaching the end, and we are indeed. So now then, there is no more full paths. Now then, so we're going to do two things here. The first thing we're going to do is we're going to double check in Git that we didn't do anything particularly silly. As you can see, this all looks good. So we'll take all those changes, and then we're going to go back to compilation and try to see what else breaks. So what we've done now is removed manually a great deal of header file functions that we think are no longer needed in this new world. We are hoping that we've also removed all of the CPP ones, because those ones we were clever enough to change the code generator first and regenerate. We will have to repeat this exercise for C# as well. But then there's a lot less formatters or text transforms in C#, so it's not as bad. Right, okay, that doesn't look too bad. Let's see. Oh, okay, that looks very good, in fact. So if we attempt to compile, now let's make sure that we have nothing on our diffs, and then we do a code generation of this, and now let's see how much breakage we have. None. That's great. Okay, so what this did then is we changed the code generator, and then we manually changed all the files, and then when we reran the code generator there were no diffs, which means that the manual changes we did match exactly the code generator changes. That's exactly what you're looking for. So we are approaching an hour, so I think we're probably going to get to the end of this video soon. We will just finish this exercise. So let's just say text. In fact, to be honest, what we'll do is we'll do C# as well in this video. So remove make full path from text transform interfaces. Okay, so now then no one is calling that function anymore. We're relying on the transform in C++, of course. Now what we need to do is a similar exercise but for C#. So I think now this is very interesting. I wonder what causes that to show up in C#. Because as you can imagine, we've changed the code generator. I'm not entirely sure why C# didn't break actually with these changes, because we only have a single archetypes here, archetype class header transform, so that generates both C++ and C# really. So we removed it from there, So you would have thought this would trigger the C# text transforms to have a removal of their header. So not fully understanding what happened here. So let's have a look at what we're doing in C#. So if I take an interface from C#, so pretty much any would do. If I just go to say built-in factory for example, the transform of course. Yes, the full path is here. So that did not get removed. That is very interesting. I don't fully understand why that was not the case. So let's have a look at how these guys get generated then. So here we're declaring an archetype. The archetype has a class header transform. The class header transform is this guy here. It's interesting when you things work but you don't know why. Ah, okay, here we are. Oh yes, yes, yes. I know why. It's because we specifically said that we're not going to do C# in the first go. Okay, that's good. So now, let's be clever. Let's do the change to this guy here first. Then let's save this guy. And now, hopefully, this will actually work in our favor, because now what we'll do is we will generate all files. What this will do is it's going to remove that entry from, well, actually it's going to generate the new code generator, and then we can generate the new code generator without that entry in it. Then we can run that code generator. That's then going to remove it from all header files, as we shall see in the diff now. Okay, so now we've done it in the right order. And now what we'll do is we will go to the C# chaps, and we will look for the templates. These templates will also, like C++, presumably have the offending method. And we just need to get rid of them. Hopefully the rest are helpers. Helpers don't have this problem. Now what we'll try to do is we try to again generate everything. Now we need to convert the C# model. And now hopefully we have something that vaguely resembles compilable code generator. Vaguely. Right, so, yes, okay, so now the problem is there is one class that was not manually generated, not code generated, which is this chap here. Not quite sure why I don't get this key binding sometimes. And if we just remove, not quite what I'd expect to have seen here. Ah, there it is. Right, now then. So all the text transforms were referring back to that header. Ah. Okay, what we did not do, we should have done first, of course, was to remove the population of the path. Let's hope that we didn't miss anything in C#, because if we did, now we're going to be in a bit of trouble. We kind of skipped the order. We did things correctly for C++, but not for C#. What we should have done is we should have removed the variable first, double check that nothing broke, and then do these removals. We did it the wrong way around. And it did break something. Right, it seems like in C# we have an additional transform that generates the CS proj that is actually relying on the full path. Oh, this is definitely not a full path, so I'm not entirely sure why that would be. Right, what we're going to do is we're going to do something. We're going to sidestep this problem slightly. So we've done some changes to these models. The changes now break something. We didn't do it the right order. We could possibly, if we're very, very careful, we could possibly say, let's just stash these changes for a second. We have to be extremely careful. And then let's modify the archetype properties, remove the file path, see what breaks, fix that first, and then resume this work. So if I just say file path changes, right, so this is just going to give us, that's not ideal. We really wanted everything to be captured there. Right, so everything has got captured there now. So now, you just have to be extremely careful that we don't break anything. This is the model with the changes that we've done to the templates. You're going to open it again. Now this does not have the changes to the templates. Just remove these rulers. Now you're going to very, very carefully here remove file path, making the smallest amount of changes possible to this diagram, and save that. As you can see, there's only one change. It's going to be quite small. And now what we need to do is to say, okay, generate everything. So the usual conversions. It just requires a huge amount of concentration because it's very easy to break everything. Okay, right. Let's just be very careful here. We don't want to pick up. We are using the latest code generator, and the latest code generator is actually trying to do more than what we asked it to do. So let's just make sure that we only pick up the changes that we're interested in. And those are going to be only the artifact property changes. These guys here are just to do with the fact that the code generator has got that change to remove that method. Right, so now then, if we attempt to run the tests now, this is going to cause, hopefully, the break. Okay, the first break is expected, the file path expander. I mean, ideally we didn't really want to do this change right now, but there you are. It's now going to cause problems with our applying the stash, but it's fine. And now I'll try to clear what we've done here. Okay. So we have some kind of trick to generate the relative path. And that trick is to use the existing path. Okay, that's fine. Actually, this probably would have been quite easy to fix now that I look at it. So the problem is just the relative path that we're creating here. And the relative path is very simple. We use the file path and then we create the relative path off of it. So in reality, we could have just simply said artifact dot properties, path properties dot path. Okay, so okay, I'm gonna take back what I just said. Let's not do this change via this very careful approach, because this is going to break something. So let's just go back again to our previous stash, and what we're going to do now is we're just going to create the stash here. This stash doesn't really matter. We're going to go back to the real work that we're doing. We're going to get rid of that, and we're going to do the real fix there, because I think the real fix is really, really simple. all we need to do is to go to the file path expander, and where this guy is asking for the artifact file path, we are going to say use the artifact itself. Now we just need to be very careful here. We are inside of the Formatables model. This pair that we're looking at is probably something like a string of formatable, and then that guy here is going to contain the region, but we're referring to the element property. So this is actually not as trivial as I thought it would be. Problem is just the shape of the objects at the moment in the Formatables model, which is an awful shape. This guy here, a formatable, is in effect roughly representing one of these slices, one of these regions in space that we now understand much better. That contains element properties, and it also contains the logical element as well as the physical region. And in the element properties, we are operating inside of a region as well, because the artifact properties map to the region. So what we're doing here is we're looping through the region, but from the perspective of the artifact properties. And then what we are then doing is we're saying, locate me the formatter, and then with that formatter we're trying to create a path. Now what we really want to do is somehow not to rely on the path that exists inside of the formatable, but rely on the path that exists in the region, because that's really all the formatable stuff is to be decommissioned. So we really don't care about any of this stuff. We're just trying to do something one step at a time. These refactorings are really tricky because of these sort of things. The element properties contain one bit of information that we care about, the relative path, well, two bits of information, and one that we don't care about. But because one is dependent on the other, and we need to break this refactor into two, we somehow now need, well, maybe this is not too bad. What we need to do now is we need to somehow go back to the formatable. So this guy here is a formatable. Well, there's the formatable. So we need to go back to the formatable, and then for each artifact property, rather than finding the archetype in the stock formatters, what we're going to do instead is we're going to say const auto I formatable dot region, so artifacts dot artifacts by archetype. So we need some reference to this guy here. Let's call this const auto by reference artifacts by archetype, something like this. What we want to do is we want to say find given the arch, and then if the I is equal to the end, then we have a problem. If it isn't equal to the end, now we got the archetype. Now I'd like you to then go to so if we just do something like const auto by reference A, which is I dot second, and then if we just say to it, please take the path properties dot file path. Right, now this may sound awfully complicated, and it is really convoluted, but let's just make sure that we don't really Yeah, we don't use this anymore. Of course, now that then means we don't. Well, okay, right. So let's just try to see if we can fight one fight at a time. So hopefully, what this will now do is this will now pick the path that we generated with the new transform, the new legacy transform. Funny enough, instead of using the previous path, and that would then give us the relative path that we need to for that transform. This is this refactoring is required. In a way, they are quite interesting, really. But they are, I mean, everyone wants to work on the stuff that really delivers value rather than refactoring. Okay, that doesn't actually look too bad. Seems like we. Well, it seems like we just need to update the C# model, I think. No, in fact we do not. Not sure what that diff is all about. Let's look at the diff more carefully then. Actually I know what the diff is all about. We need to update the C++ model as well. So let's just do that. Oh. That will show us the diff, which is what we want. So after a great deal of thinking, I mean this was supposed to be a quick thing, we already are an hour and 15 minutes into it. So what we have achieved here was we somehow managed to obtain exactly, now this works perfectly right. So let's go back to our Git. Okay, so we managed to remove the makefile path from the interfaces in C#, although it was much more complicated. But it worked. So okay, something didn't quite go as expected there. Where is? Okay, I think we may have committed by mistake our agile log, but it doesn't really matter. Okay, now then let's do the last bit of this work, which is to try to get rid of make sure we got the let's go generator. Now let's try to get rid of that member variable by regenerating the models. We need to do the usual conversions. So not C++, C#. Right, so now then, if all has gone according to plan, we don't really need this stash anymore, so let's drop it. As if all has gone according to plan, with a bit of luck, we would have removed the properties, the file path properties from the formatable. And also this in a way, this is a good way to demonstrate just why we are taking so long to do these refactors. I mean, as you can imagine, just to remove one property from one of these objects took us such a long time. And you can imagine we're trying to do some massive refactors. It requires quite a lot of meta modeling. It is almost impossible to do these things without doing it step by step. So that looks good. And if you just regenerate all these guys, everything looks great. Okay, cool. So now what we're going to say is remove full path from artifact properties. Righty, okay, so that was quite good. We managed to get a lot of stuff done. And now we're using the new transform, the new legacy transform. Quite like the name that the new transform is already called legacy. And that resolved a lot of problems in the formatables, but of course the real target is going to be to get all of the stuff that depends on locators so that we can finally remove all of this locator stuff, which means that the next big target is going to be all these relative paths. In C# we only have that one use case, which is very simple. In C++ we have the very big and complex use case of inclusion, which is going to be a lot of stuff. So that's all for the next video. Thanks for watching.